Hi, I'm Sreenath Balakrishnan. I graduated in March 2018, and currently I'm an assistant professor at the School of Mechanical Sciences at IIT Goa, and I am also associated with the School of Interdisciplinary Life Sciences, where I'm currently the program chair. So I had a very nice experience at the bioengineering department at IISc. I was part of a first batch. And if I have to think of several things that happened, I mean, if you want to categorize the experience, I think we'll have to go through multiple areas. Let's say first, if you start with academics. So one of the things that I remember very clearly is that the faculty there had a very clear plan of the course structure. So, for example, um, we were supposed to take 6 or 7 courses, of which four or something or four courses. So if you look at the other departments at IIC, they would do like I think 3 courses or something. So they had a very specific plan on what were the core courses. So we had to go through those courses. So if you ask me personally, we had a few engineering courses, which was not very difficult for me because I come from a mechanical engineering background. But we had this bio course, which was actually quite difficult, and it really prepared me for the research that I had to do later. Also, there was a very interesting course called Practicum, where you had to propose some research work in one of the labs that you would work in. And then you had to do that, and then you had to present it. And that was, um, to put it mildly, it was a very grounding experience, the kind of questions that the faculty used to ask, and it really prepared us in our research, how rigorous we have to be in our research. So that would have been the part about academics. I would say the highlight was when I look back at it was that the faculty who actually started the department had actually well thought out, had very well thought out plans on how to prepare the students for the research. Now, if I were to come to the next aspect of my experience, which would be research assets, um, so there one of the things that stands out is the rigor, in the sense that we had to give these annual progress seminars, and the amount of questions that we were bombarded with. It really helped us to shape our research, to shape our level of doing research, of understanding of various aspects about for the work that we're doing. Also, another thing that was emphasized early was that we had to have two advisors, one from engineering and another from biology. Uh, so that was kind of mandatory uh, for our batch. So all of us in that batch, we had two advisors. So we really had to bring together these two disciplines, and we had to master both of them. So that was a very, very challenging aspect that all of us had to face. And I think it paid very well for us because we had some really good publications coming out of the stuff just from our batch itself. Uh, so that's pretty much what I would have to say about research. The other thing that was very interesting for the bioengineering at that time was we had a lot of co-curricular, extracurricular activities. So, for example, so when we joined, we were all given a book by the chair of the department. So the book that we were given was What is Life, and the after the first or second semester, we had a book discussion session where the batch of students who were given the book, they were supposed to lead the discussion, and so this I know it happened for the 5 or 6 years that I was there. So in the second batch, there was some other book, and each of them were related in some way or the other to this aspect of bioengineering. So that was a very interesting activity that we did as a department. Another thing that I would remember is we used to have this summer trips, and I cannot forget this trip to Lepakshi Temple, which is in Andhra Pradesh, quite a little, maybe a few hour drive from Bangalore. And the book discussion for that year was actually organized inside the temple. So we were discussing this book, The Emperor of All Maladies by Siddharth Mukherjee, if I'm not mistaken, uh, in Lepakshi Temple, which is like a 500 to 600-year-old temple. So I would never forget that. Then another extracurricular activity which we were all very excited was the open day. So we would all make some or the other um, new new jigs or something, or some new thing to to demonstrate the bioengineering aspect. And I think ours was one of the very well received exhibits in the campus. So that's one very interesting part, that extracurricular activities which we really enjoyed while we were in bioengineering. The last point that I would say is the amount of support that we received in the department as well. So by the time we had joined, there were a lot of instruments that were there. So for example, we had very nice confocal microscope, we had ASM, we had a few other instruments. So for example, in my case, I have used the confocal and ASM quite a bit in my research. And the fact that these instruments were there and they were purchased and they were already there by the time we started, it really helped us to shape our research. And I kind of um, made sure that my research is around these instruments which were there and which I had easy access to. Especially the AFM, we had a very good technical support for that. So we could do a lot of experiments and get a lot of data. And all those support from the department was very helpful. One part I missed about the extracurricular activity comes to my mind is that after a few years, after we started uh, the department, maybe 3 years later, we used to have this happy hour, which is once in a month. I forgot one day of the month, first Monday or something, where we would all gather, and then there was one activity was that we would cut a cake. The cake would have names of the people who had written a paper in that month, who had a paper published in that month. So that was one place where all of us gathered together, and we could celebrate each other's success, and we would also understand what kind of work the others were doing. So all put together, this was a very complete package that the faculty had prepared, and also because of all these common activities that we were doing, there was a lot of camaraderie between the various students in the department. So yeah, so it was a very good experience. So if you ask about the people who fit, many of you would know that IISc is a very nice uni campus, and there are so many things that I can talk about, and then but I will restrict to maybe 4 people that I found really touched some part and made a lasting impact. So maybe the first person would definitely be my first 2 people would definitely be my advisors, and the first would be Anand Suresh, who was my PhD advisor. So the things that I learned from Anand Suresh, probably I can write a whole book, but I would just stick to a few. Um, so um, I think in terms of research, the main thing that he taught me, one of the main things that he taught me, obviously the technical aspects of the work, mechanics and mechanisms, everything. Obviously, that those are there. But apart from that, he kind of told emphasize the fact that when you are looking at somebody's work, you should be able to judge the intellectual contribution that is there in that work. So he would judge a work not by where the glamour of the journal that it is published in, or under whose lab, from whose lab that work has come, but from what is the intellectual content. So where was the field till then? What was not unknown, and what kind of an intellectual jump was there in that paper, or in that thesis, or in that work, or in that talk. So what people did not know before that paper, thesis, or talk was there, and what is the new intellectual jump that was given by that particular author or author. So to judge a work by that was very important. So that was, I would say, one of the most important aspects that was taught to me by Sri. Another important thing is to be a good citizen. So there is a tendency in people, students, faculty, in companies, etc., to be complaining about whatever is happening around you. So let's say if you are a student at a department, you would say that this is not there, that is not there. So that kind of a thing is there. I mean, even though you can complain, but it is important to be a good citizen, to contribute to your environment, regardless of whether you are a student, you are a faculty, you are working in a company, wherever you are. To be a good citizen of your immediate surroundings is super important. And I think he really emphasized that, and he lived it. He lived that motto also. In the sense. He has hardly said no to any academic responsibility that was given to him, be it being a chair or dean, or whatever. So that I think was a very important lesson. The third uh, aspect, to be a genuine person. That I think is that to be what you say, like in the sense that you profess something and you have to live up to it. So I have a very nice example for that, because Suresh used to tell me that so where he sits, he used to have all of the pieces that were submitted by the students from his lab. Those pieces, the bound volumes, used to be there behind, and then he would often say that the thesis is actually more important to me than any paper that I would publish. Which was actually quite strange to me at that time, because people would often see the papers that you publish, but the thesis hardly people would read. So the papers are more accessible. I would think that somebody would take more effort on the paper, but Suresh would say the opposite. That the thesis are actually more important to me. So I was not convinced by that answer at that time, but I was convinced when I started writing my thesis, because uh, so what used to happen was I would write a chapter and then I would give it to him before he leaves to his home. So that's around 6:37 in the evening. When he's leaving, I would take a printout and give it to him. And always the next day morning before he comes, he usually come around 8:30. And by 8:30, he would have corrected the thesis, and he would have actually kept it on my desk. He would come slightly earlier than me, and then he usually comes. So he would keep it on my desk. So he used to live up to this to his words. So I learned that it is very important to be a genuine person. So that's probably the three most important things that I learned from Cyril. So second person whom I want to talk about is my other advisor from microbiology and cell biology from the biology background, Professor Amitra. So the first day that I met him, I was actually very apprehensive, because I'm from a mechanical engineering background. So biology, I mean, even though I wanted to do bioengineering, but I was always, I mean, in the beginning, I was apprehensive of actually getting into biology. So he told me something which still is very central to the confidence that I gained to do this research. So he told me that uh, maybe the things that you learn in school about biology could be boring, but practical biology is very interesting. So that's how I approached my biology. So I was not, I mean, I don't think I can read through some of the core biology textbooks like Lenin's or something. I still can't read, because that's not what excites me. What excites me is practical biology. So that thing was a very good advice to me to focus on the practical aspects of biology, what you can do in labs, what you can see under a microscope. So those kinds of things were actually very important, and I am very thankful, because he said that's probably one of the first few things that he told me in the first meeting that I had. So one of the first few words that I heard from his mouth was that. Uh, Second thing is that he's responsible for uh, the primary direction of my thesis, in the sense that so my thesis was on the nuclear mechanics in the case of hepatitis C virus infection. So he's the one who told me, okay, why don't we look at nuclear shapes in the context of a field? So that primary direction was given by him. Another thing that I fondly remember uh, now, maybe at that time it was quite stressful, was all the lab meetings that I had to attend. So every Saturday 10 to 1 was a lab meeting in front of the lab. It was in the beginning it was a very stressful experience, because you have to show your progress, and you had all these people who are talking about biology I would not understand. But slowly, because of those lab meetings, I really started understanding the many aspects of biology, and it was really helpful to me. So it took me almost 3 years to start really understanding what I was talking about. But I think if you look at my career trajectory, those lab meetings are still, I think it was very important. So the next person whom I want to talk about is Professor Narendra Dixit. So as I was telling you about the lab meetings in computer graphics lab, so there was one student who wanted to do some kind of mathematical modeling, and this is from computer graphics lab. And then for doing that mathematical modeling, he asked whether I can do. So somebody was also asked me. So then we started working on the mathematical modeling, and then obviously I did not know much about that. I'm a both mechanical engineer, so I did not know much about the mathematical modeling. So we had to get some help, and then Narendra Dixit was a person who used to do that kind of work, and he was also associated with Bioengineering. So uh, we contacted him, and he was happy to help. But his working style was different from Suresh, and and I remember this very fondly. So what Narendra Dixit, he was very systematic, and so in order to meet him, you had to always write up something. So you had to write, what you have done, and let's say you have to write like what is it that you are not understanding, and you have to send it to him, and then you can get an appointment. So and then let's say you have a meeting, let's say from 2 to 3, and then when you go there, he would have actually read it. He would have read it and understood it. And then in that an hour meeting or half an hour, 1 hour meeting, you would discuss very deeply into what is working and what is not working, and why. And once and when you come out of that meeting, you would actually know what to do next, and then you do it, and then you go to the next meeting. So I'm probably and we ended up co-authoring a paper together. uh, I think probably I would have met him 6 times or 7 times, but each time I went with a problem and I came out with a way forward. And then probably I would get stuck in a different part. And so over a period of 6 or 7 meetings, we could actually solve it, and then which probably took a few months. So that I think that way of working, very systematic, and not wasting any time. Like for example, if I had gone there, just asked for a meeting and gone there, it would be a waste of time for me as well as him. So he ensured that we stay on track. The last person that I want to talk about is Professor Kaushik Chatterjee. So many of my batchmates and juniors were advised by Kaushik Chatterjee. So I know him through them. So even though probably during my PhD I have not had a direct interaction with him within a collaboration like I had with the others that I was talking about, but I know him through them. And two of the things that he has told the students. Uh, those two things actually comes to my mind, and has been very important. So one of the things that he says is to pick your battles. So which I think is a um, very important thing to note in, let's say, corporate kind of, or any kind of industry, academia, any kind of work environment, or even in the lab. Like in the sense you can have issues with multiple people and multiple problems, but you should choose your battles, and you should know where to let it go and where to um, to really put up a fight or something. So where to respond and where not to respond. So picking the right battles is important. The second thing that he says, and which I found very helpful, is what doesn't kill you makes you stronger. Maybe slightly different words he says. But this is also important, because you are going to have a lot of tough times um, inside and outside of work. And if you are not down and out, then that means you have just become slightly more stronger because of that experience. So if you ask me, so all of my research problems that I work on now in my lab are all related to bioengineering, the sense that we are applying mechanics to biological systems. Uh, so, so in a sense, all the problems that I'm working on in my lab right now come from my bioengineering training uh, in the bioengineering department. But apart from that, from a more, like you say, more kind of slightly more on a philosophical level, what I think helped me more than that is the confidence to work on unfamiliar topics. So, for example, because I come from a mechanical engineering background, and the first time I learned biology after my 10th standard was during my PhD. So I so if you have an interest, you can actually work on things that you don't have immediate familiarity. So that is something that confidence to be able to do that is, I think, something that I have gained from the bioengineering department. So, for example, I have done a few work on epidemiology of, during COVID times. So that I mean, I hadn't done anything like that until then. So, but I was confident I could do it because these are also some differential equations which I knew how to manipulate, and then I knew how to interpret virus infection and how that could affect population. So I knew that I could interpret all of these because if I could do cell biology or cellular assays, how difficult can manipulating a few equations and to understand. So I mean that kind of a confidence that I got from the bioengineering department. Another example would be that now I'm also working on some marine sciences concepts. So that also the primary confidence to work on such different topics actually comes from my time in the bioengineering department. So there are two things that I think are important that comes to my mind. The first thing is to look at biology uh, from a physical standpoint. So, for example, when I had to do my comprehensive examination, and since I am present from an engineering background, one of the subjects had to be biology. So, I was unable to learn biology from a traditional biology textbook. So, what I did was I used this textbook, Physical Biology of the Cell, by Rob Phillips and a few others. And that textbook really helped me to really understand the concept in a different way, in a way that uh, in a way that was palatable to me. Because a person from an engineering or physics math kind of a background, I find it always very difficult to keep a lot of facts in my mind. I need to be able to arrange them in terms of some physical principles, so that you learn that principle, and the rest of it, the things can be derived from that. So that's the general physics engineering perspective. So by learning biology from that kind of a physical standpoint is very important to me, and I think definitely as engineers, everybody should learn from that book, and I think it's even useful for biologists, people from a more biology background who are coming into the bioengineering department to see that point of view, to take to read biology from a physics or engineering point of view, use such books to learn biology would be a very, very important exercise, I think, for anybody who's aspiring to be a bioengineer. The second thing that my second advice would be to come out of your comfort zone. So, what I mean by that is that if you are coming from an engineering background, you should try to learn and do biology. Uh, rather than just or so you have to really try and do some biology rather than just use it as your system of choice. But whatever you're doing is only the engineering part of the physics part or math. So try to do, I mean, or if you are a biologist, try to learn the engineering aspects and do some modeling or something. So this coming out of a comfort zone should be there. I think should be there both from you can try both from between the engineering biology thing and between, let's say, computational and experimental. So what I suggest by that is if you come from computational background, try to do some experimental stuff. Try to have some experimental aspects, or if you come from an experimental background, try to have some computational aspects. Also, and you do it across the engineering and biology axis also. So you try a few things. If you are coming from a biology background, you try to do some engineering things and engineering to biology things. So that way, I think you will become a well-rounded person. Um, researcher. But I mean, I would like to warn you that that is difficult. It's quite difficult to do that. But I think it's really worth it. So if you ask me personally, I prior to my PhD in my BTech and especially in my MS, I had done engineering work and computation. During PhD, I have spent a lot of time doing biology experiments and generally a lot of experimental work and biology work, so as to be able uh, to have that aspect in my research also. So now, if you look at the way that my lab works, we do modeling, we do design of, we build instruments or instrumentation, and we also do biological experiments. So, I think it's a more well-rounded lab, uh, thanks to the Department of Bioengineering, as well as because kind of focused on on going out of my comfort zone and actually making me more of a well-rounded person. And not just me, I have seen a couple of my friends also do this. So that I think that actually